Hi, I would like to introduce our speaker for today, David Hale. He is a school teacher with Olentangy School District. He's been there, I believe, 16 years now, and he has a degree in education in math, from Ohio Wesleyan. Got his master's in, I had to write this down because I hadn't heard of it before. Instructional Technology from Ashland University, his master's degree. He is going to come and speak with us today about using high tech in the classroom. Thank you.
All right, all the devices that scare me.
That's right. Thank you. It's good to be here. Thanks again for letting me have a free meal in exchange for just talking to you guys about some things that I do in my classroom. I am an employee of Olentangy Schools. I teach at Olentangy Liberty High School, and this is actually my 17th year, frightening enough, of teaching at overall and 16 at Olentangy. But today I'm going to talk to you a little bit about some of the technology that we use today specifically in the math classroom, but a lot of these things are used regardless of what area it is that you're teaching. So to begin with, they're going for it? Do I need to point at that? That's perfect. Okay. One of the issues with technology is it has to be able to work in order to be good. So that was a plan. Yeah. So one of the first things is I have a smart board in my classroom. I don't know how many of you guys are familiar with the smart technology. It wasn't there when I was in high school, but it's something that I use essentially every day. It's basically a board that's at the front of the room that allows me to, by touch, be able to interact with everything that's on my computer, which means that there's no longer any chalkboard or anything like that, or when I first started teaching we had a dry erase board. I don't have that at all. Instead, everything's done digitally. When I do my lessons, I can have kids go up to the smart board and they grab a pen and they just write on the screen, and that ends up showing up. The smart board, it's just great technology. We can do lots of great things with it, and we are heading to a stage where it's even making it so that we're using less and less paper because of it, because we can do so many things, we can make so many presentations without having to have paper. So anyway, so the first thing I wanted to talk to you about is just the smart board and things that are involved with that. Then this is the thing that I do for my class on the first day. I do have a couple of examples here, some visuals. This is one of my clickers, and if you'd like, if you want to check it out afterwards to see what it actually looks like up close. Here it is, just as a digital version. But these clickers, what I do is I have my whole class, all of my classes, entered in by their student ID number. And what the kids do is they can log in using their student ID number. And using these clickers, I can ask questions during the lessons, and they respond. They can either type in, I can give a multiple choice type question for them. I can give a number answer where they just have to type in what the solution is. You can do it. It's got the letters where if I were in an English class, I could do it with them typing back a word or something. But it can be true, false. But what it allows me to do as an educator is to no longer have to say, do you understand what I'm talking about? And hope that I get a response. I don't have to hope that there's kids who are nodding their head yes or shaking their head no or putting up a hand if they don't understand something. It's much more a way that I can say, all right, well, I've done a couple of examples. I've showed you how to do this material. Now let's see if you actually understand it. So what I can do is I can just say, all right, I've got a clicker question for you, and here's kind of what one looks like. So here you can see it after I've done the work. Again, this is from my smart board. This writing in here wouldn't be there. Instead, it would just have convert to decimal form 6343 base 7. I don't know if you guys are familiar with other number bases, but anyway, that was the question I asked for my discrete math class. And so on the left side of the screen there, you can see that 58% of the class got the right answer. The green shows how many of them got it correct. So I did a couple of examples. I asked this question to the class, and then, okay, well, there are several people who didn't get it, who didn't quite understand what the correct answer was. And it also shows, you can hide this legend or make it show, but it also shows their responses. So beyond just seeing how many got it right, how many missed it, I can see exactly what they responded with. So again, it lets me as an educator be able to say, oh, you missed this one because, oh, you forgot to carry the one, or whatever it happened to be. But again, it makes me a much better teacher, because instead of me, do you understand what I'm talking about? And most of the kids are like, eh. Instead, I can tell right away, do they actually understand what I'm talking about? And specifically, I can tell who does and who doesn't, because I don't have it showing here, but under the details, it'll also let me know how quickly they responded, and it'll let me know how many of them got it correct and how many missed it specifically. So I can say that Dave Hale missed this question and this is what he replied with. So again, it lets me look back later and be able to draw some data about, oh, this kid, I really need to get to him because he's not understanding stuff. Or on the other hand, we could have we could have a situation where it was like this one, where this was the next question. So after I did that previous example, I said, okay, well, let's talk about it. I showed the work that you saw in blue ink there. So here's another question. Let's see if you can do this one. So now convert 7,508 into base 7. So I asked this question. I gave them time to work on it. And again, as an educator, it's another thing that we kind of work on is it's called wait time. And as an educator, you want to allow enough time for the students to be able to think and process and see if they can figure it out. And if you're going through a lesson, a lot of times without this, it's real easy to give them a minute or two, but hey, I want to make sure I get this in and get this in. And this really lets you slow down a little bit and see what they actually understand. So this time I had, 92% of the class got this question right. Now I still worked through it and showed them how to do it correctly for that one or two people who missed it. But again, it's just an excellent opportunity to be able to get immediate feedback, which is something you don't always get. You teach them new material, and then there's a test. Yes, sir?
I got a question. Can you tell us what you did there?
Sure thing. So that's a great question. By all means, if you guys want to learn math, that's awesome. So what this is right here, this number 7,508, that's in our base 10 system, which is what we normally do when we do math, is we're used to using a base 10. And honestly, a little bit of history here, it's base 10 because we have 10 fingers, and that's how we count. You count to 10 and then you start over again. You may have learned back in the day in elementary school, you have a ones place, you got a tens, a hundreds, a thousands, a 10,000s, and keeps on going. Well, there's nothing really special about base 10 except that's what we use. That's what you've been used to. That's what you've done since you've been in elementary school. But you can have a number base of anything, really. And this is converting into base 7. Now, before I show this one specifically, there's also bases that are used that are not base 10 that are used frequently. Computers are a great example. They really, at the most basic level, are what's called binary. And binary means base 2. A computer only knows switches on or switches off, a 1 or a 0. That's base 2. All right? In base 2, you only have 2 digits, 1s and 0s. In base 7, you can have digits that go all the way up to, but not including 7. You can have 7 digits, just like, and this is an interesting thing, well, I think. In base 10, we really only have 10 unique symbols. You have the symbols 0 through 9. After you get through 0 through 9, then to write the number 10, we actually put a 1 and then a 0. Well, technically, 1, 0 just represents I've got a 1 in the tens place and a 0 in the ones place. So that's kind of what's happening here. In base 7, what we're trying to do is we're trying to get a number that equals in base 10, 7,508 from base 7. So in base 7, instead of having a ones place, a tens place, a hundreds place, we have a ones place, a sevens place, a 7 squared place. You know, normally you'd have a 10 squared place for hundreds. That's why it's called hundreds place. The next place would be a 10 to the third place, which you think of as thousands place, but if you're in base 7, it's a 7 to the third place.
What's the practical application?
Well, the practical application in terms of...
You pass the math course.
Right. One, you'll pass my class. But
exercise, Jerry.
But this really, the practical application of this is, in computers, like I said, they are binary. They're base 2. And computer programmers, they often will do programming in hexadecimal, which is base 16, or in what's called octal, which is base 8. So base 7 specifically, I don't know if there's real practical application. It's not like you're going to walk down the street and do your math in base 7. But I also talked to the class about some of the history behind how number bases are developed and that sort of thing. The Mayans, they had a base 20 system because they had 10 fingers, 10 toes. And when they were counting, they had a slightly different system than what we use. We use what's called a positional system, which is why the position the number is corresponds to what power the base is. The Mayans didn't have that. They weren't as advanced in terms of their mathematics. What they had for their system was just they had a symbol. So the number of symbols you had told you how many you had. So it's a little bit more basic, but you can't. It's really much more difficult to write big numbers. This is kind of the more advanced system. I also talked to my students about how to use numerals in Chinese. I show them some examples with Chinese numerals, and for their system they have a multiplicative system where they have a multiplier and then they have a symbol for the base. It's not the position the thing is in, it's a multiplier times 10, or a multiplier times 100, or a multiplier times 1,000. And they have a symbol for each of those things. Anyway, does that help a little? Sure thing. So this problem specifically, what I need to do is I need to, in base 7, get enough to add up to give me 7,508. So the first thing I do is I start writing 7 to the 0, 7 to the first is 7, 7 squared, that's 49, 7 cubed is 343, 7 to the fourth is 2,401, and then 7 to the fifth is that number times 7, which is way bigger than the number I'm trying to get to. So once I got to this point, I said I don't need any 7 to the fifths or to the sixths or anything past that. All I'm looking for is the biggest number that'll go into the number I'm trying to get. So it turns out that if I do 3 times this 2,401, I end up getting 7,203. So that's how many in base 7 I've accumulated so far. I'm just basically trying to add stuff together to get me my total of 7,508 in base 10. So if I take 3 of these 7 to the fourth, that gets me a 7,203. If I subtract that from what I'm going for, that gets me a 305. And then to get 305, well, my next number base is 7 to the third, which that's 343. That's too big. So I don't need any of those. So I move to my next number, which is a 7 squared. That's 49. If I do 6 times 49, that's 294. If I subtract that, that gets me 11. To get to 11, I'll take a 7, 1 in the 7's place, and I'm left with 4, so I'll take 4 ones. That's how you get it. Yes, sir?
I missed. What age are these kids you're teaching?
What age are these? Oh, yeah, I'm sorry, I probably should have said it. This class right here is a discrete math class. The age of the kids in here, I have some seniors, I have some juniors. That's a class that they can take anytime after Algebra II. But I typically have seniors and juniors in that level class.
I guess I'm astonished because I learned a program 55 years ago.
Yeah.
And you learn a whole bunch of different bases.
Yes.
I think it's amazing that those kids can deal with different base arithmetic like that. That's
Yeah.
a whole different world.
Absolutely. I've got a project for them that's, it's due this Friday, where I'm challenging them to create their own number base. their own number system, I mean. So they're allowed to choose what number base they want to have. They can choose their own symbols, and then they're supposed to come up with what their culture is, the reason why they did it, you know. I talked to them, I said, you know, in the world of The Simpsons, you know, Bart and Homer and all those guys, if you ever watch The Simpsons, those characters, they only have 4 fingers on each hand. So I said, if you were living in The Simpsons world, they would probably have a base 8 system, because they've got a total of 8 fingers that they can count on at a time. Thanks. So, yes, Mr. King?
Curiously, you mentioned that you can tell how fast they answer the question. So, what did you typically see for that example in response time to get it right?
This response time, well, let's see. I stopped it. That's duration for doing both the two things. This one, I think it was probably around 3-4 minutes, something like that. 3 to 4 minutes. Now, again, depending on. This one was done as I was teaching that material. This was my notes from day one. I can see at the top there. So this was first day of notes. I just introduced the concept to them, basically. I take that back. The day before, I kind of give them an exploratory type thing. Here's another example for when's this used. I gave them an example of pigs. You guys know anything about with pigs, how they're marked? I had an article that I gave to them about that the way pigs are named according to their litter and according to the specific one is a base 3 system. And if you look at the pigs, they would notch the ears of the pigs. And however many notches they had corresponded to a number in base 3. So you could, based on how many notches they had, that would tell you which litter number the pig was from and then which specific one it was within that litter. Interesting stuff, I think. That's me, hopefully. Anyway, so once I do those clickers, I'm able to collect a lot of information from it. So I use this a lot when it comes to parent-teacher conferences, because here I just erased the kid's name and put in Joe Smith. There's not really a Joe Smith in the class. But anyway, here is an example where I can show the student performance by assessment. So each one of these little things down here is showing all the times I did a clicker question, how the student performed, and then also what the class average was on that same assessment. So in a parent-teacher conference, I can look at this and say, you know what, Joe, for the most part, he's hanging with the rest of the class. You know, sometimes he's a little bit above, sometimes a little bit below, but he's more or less with the rest of the group. If I had a situation where the student was below the class average consistently, that's a conversation I can have with the parents and say, you know, maybe he's not getting it as we're doing the material. He might need to spend a little bit more time with it afterwards, or you know, I can show you some of the other resources I have here in a little bit. But it's a great thing for me to be able to have those kind of conversations with the kids and with their parents, to be able to say, hey, here's how they're doing. As opposed to saying, well, I think they're doing okay. I've got a little bit more data to support it. And then I can do this even for myself, comparing. Here I've got 2 of my discrete math classes. The average doesn't really mean a whole lot because I teach 2 of them. It's halfway in between. But you can see here that my 9-10 discrete class is way outperforming what my 3rd period discrete math class is. Which for me as a teacher is a little bit challenging because it's the same material. It just so happens that the group of kids that I have in 3rd period, it takes them a little bit longer in order to figure out how to do this stuff. And I can say this in terms of personnel. My period 9-10 class is a smaller class. I have 13 that are in that class. It's really small. I have double that in the 3rd period class. It's just the way the scheduling worked. And also out of those 13, I think 3 of them are also in my AP Calculus BC class. So they're strong math students. So it's not entirely surprising that the one is outperforming the other. But again, it's things where I can use to be able to compare, even amongst classes, what's happening with them. So now, those clickers are things that I wrote a grant in order to get my smartboard and to get these clickers that the kids do the response stuff on. And again, if you guys want to see these things, you're more than welcome to check them out. This is a new thing that our district is doing, which is called ThinkGate. It's a website where it'll let you do essentially the same sort of thing as what I can do on the clickers. The difference is that ThinkGate, I can ask the kids to do an assessment online, so they could be able to do it at home, and I did that a couple times here. Gave a couple of assessments to two different classes, one to my BC Calc class and one to my Discrete Math class, where the assignment was go home, do this assessment, and we'll talk about it the next day. So I can, again, have them do it, and then we can come in the next day. It does a similar thing with letting me know the results, so I can see which questions they missed, and we can go from there about how to actually attack them. But just another thing that, again, when I was in high school, the internet really wasn't anything like this at all. And now the ability to give assignments and be able to have the kids do them, it's pretty neat, the stuff that can be done. This is another thing that I do with my class. We use this website. It's called Schoology. And what it is, it's kind of a place where I can put any and all information that I want my class to be able to access at their own leisure at home. So what I do is, for my classes, for my PreCalculus BC class, one of them, I have some folders up here that kind of show the different topics that we're doing. Right now we're doing the parametric polar and vector unit. In that folder, I have resources for them. The first thing is I record all of my lessons. I've got a little microphone that I wear when I teach the class, and what happens is everything that I do up on the smartboard gets recorded along with my voice as I'm talking through the lessons. So what happens is if a student's absent, or if a kid doesn't quite understand exactly the material that I did in class, or if they in class wanted to make sure that they took the time to understand what it was that I was saying, and then when they went home they wanted to go a little bit more into the details or write some specific examples down, this gives them an opportunity to do that. They can just go home and they can play my video, and the only thing they're missing is looking at this, which is not that great of a loss. They get to see exactly what I'm doing. They get to hear my voice explain the problem as I'm doing it. It's another great resource. And the other thing that I put on here, let's see if I click on a specific. So here was specifically for when I did differential equations, Euler's method, and slope fields. So you can see here I've got my notes for each one of the different things. Here's a review and the key that's posted. So I had the discussion with a parent about the stuff last year, and he said, well, you're really making it hard for kids to come up with excuses. And I said, yep, that's the goal. Because that's the thing, is if you miss class, you no longer have to say, hey, can I get your notes from yesterday? It's not like that anymore. You can just go on to Schoology and you can hear me do the entire lesson. You can fast forward through when I'm boring. You can rewind if there's something you didn't get. It's all up there. And then, like the worksheets I put up there, the answer keys to the worksheets, so that they've got access to all of that information. And that's just on my own particular Schoology page. Of course, there's other resources online. There's that Khan Academy. If you've heard about that, they've done some like 60-minute reports on Khan Academy where the guy puts up free YouTube videos essentially on how to do different topics. And it's just an amazing amount of information that's there for the students as long as they have the motivation to actually do it. Like I said, we're really taking out the excuses and putting much more on the kids of, well, so why, if you didn't understand, why didn't you understand it? The material's here. You could have, if you didn't get it, you could have watched it 4, 5, 6 times. No big deal. If you didn't like the way I did it, go look it up online. There's thousands of videos doing every single type of concept you could think of. So anyway, so that's where we're heading towards. Another thing up here that you can kind of see, I've got a help discussion area, so that if the kids are working on this unit, they can post a question there, and it's something that either I can answer or anyone else in the class is able to answer. So they can be able to help each other out through doing the material. This is just showing a video. I don't know if you guys want to see it or not. It's me doing a thing in Discrete called a method of successive differences. This is just a video of, and you way don't want to watch the whole thing. But just showing, this is just one of the video clips that's posted up on Schoology. Do you need me to hold the microphone to it?
You could figure the odds for us.
Yeah.
What it is a technique that you can use in order to figure out the next number in a pattern.
We want to be sure to have time for questions.
Sure thing. I can whip through things here real quick. Again, it's just showing me doing the stuff on the smart board and
next number.
Oh, there we
Okay.
go.
But if you can't figure out what the pattern is, this method of successive differences will sometimes help you figure it out. Okay? So let me, I guess, go through what it is. Given the sequence, find the next number. So I've got 2, 6, 22, 56, 114. Do you have any idea what the next number is going to be just looking at that list? Probably not. It's not one of those obvious things where I can say, okay, well, to go from one number to the next, we're adding 6, or we're dividing by 2. There's nothing that's directly obvious on this, okay? So, what we can do is, this method of successive differences, which it's kind of describing what it is that you do.
All right,
Between
you can stop this here.
successive numbers, you find the difference between them. So you
If you want to, I'll give you a little side lesson if you're interested in actually. Some other types of technology that we have. This is what I have on my computer screen. Again, with my smart board, I have it's called Smart View for the TI-84 Plus. I also brought some new graphing calculators here. Well, not new, but some graphing calculators here if you guys haven't done anything with those. But this is, again, what I can show to my kids as we're doing problems. So in BC Calculus, we're studying polar graphs. So what I can do is I can type in the equation of this polar graph. The kids can, at the same time, see what the equation is, see what the graph looks like, and also see a table showing the relationship between the angle values and what the radius is. So that they can see graphically and numerically exactly what's happening to the curve all at the same time and see how the things interact with each other. So again, it's just a great tool to help the kids understand a little bit deeper what's happening. Again, back in the day, you had to create this first in order to actually graph it. And now we can say, all right, well, once we do a few, we understand how the connection works between them. Now let's go a little bit further and do some more analysis of why it does what it does. Couple other things here. This is just where I do my attendance and my grade book. That's all kept online. I don't have a physical grade book. I don't do my attendance in an attendance book. It's all online. I go to the Power Teacher here. I click on the class and I can create my seating charts there. I can click who's absent and that sort of thing. Put it up there, and then for my grade book, it's just all online. All the stuff is entered in there. Now this is something I just learned about, I'd say a few weeks ago. There's an app for your phone, it's called PhotoMath, where it'll be able to solve simple equations, all the way up through like maybe Algebra II-ish or so. It can solve it. You just hold your phone over the problem, it scans it, and then it tells you what the answer is. It works it out. You can see here it says x equals 5/2 for simplifying that. Or this one right here, it's got this algebraic expression, solve that for x. The cool thing is that it does show you the steps, so it's not just mindless, here's what the answer is. Now, as far as from a teacher's standpoint, obviously this is swell for checking your work, or if you're not really sure how to do something from the beginning. Obviously, on a test, I wouldn't let them have their phone out. Which is an adjustment. When I first started teaching, first of all, hardly anyone had a phone, a cell phone. And then, yeah, they had a smartphone, but you're not going to do anything with it. And now, before they do any test in my class, I have a little pouch. It's an old shoe container, where you put shoes in little pouches, whatever. So I got one of those at the front of the room, so if the kids have their phones, I say at the beginning of the period before we do the test, all right, kids, phones in the pouches, just so that because, the phone's a little mini computer. You can look up whatever you want to on it. And then I think I have one last thing. Is it on here? Or is that not on there? It didn't go on there. There's one other thing I do in my class, and then I'll stop and answer whatever questions you have. I have another system that's done on the phone. It's a free app that's called Remind. It used to be called Remind 101, but it's a way that I can send a message out to an entire class, just like it says, reminding them things. So if we have a test coming up, then I can send out just through text message. I can just send out the text, and it'll go to everyone in the class who signed up for it. The cool thing about it is that I don't know the kids' phone numbers. They don't know my phone number. It's a double-blind system. So I just go to my app for Remind. I type in the message for whatever class it is, and it gets sent out to their phones from the Remind system, not from my own cell phone. And it's a great way for me to be able to communicate with the kids, remind them about a test, or hey, you got a project coming up. Or it could be something where, hey, tomorrow you're going to need your books in class because we're going to do some problems straight from that. So make sure to bring your books tomorrow. So it's just another cool thing. I also coach volleyball, and so I use it for my volleyball teams as well, and say, hey, tomorrow's practice we had to adjust it because of we get rain for baseball, so we had to adjust it. So I mean, it's a great way for me to communicate with the kids, and I have some parents who signed up for it as well. So that they know, oh, so you got a test tomorrow, huh? I got a text from Mr. Hale. It's hard to hide from that. Okay, so questions? Yes, sir.
When is Dublin going to learn to do all these things that you do?
I didn't know. The stuff's out there. There's all sorts of things, and I really the smart technologies with those clickers. Like I said, the think gate's another way of doing it. There's all sorts of different ways to get that same goal now. For that smart board and for those clickers, I had to write a grant for it, but I wrote the grant because it's definitely worth it. Like, it's definitely changed my classroom completely. Well, for the grant, I did it through. We have a system called the Olentangy Education Foundation, and what I did was wrote the grant. It was for a class set of clickers for the smart board, for that TI graphic calculator emulator screen, that sort of thing. Oh, gosh, and it's been a while now. I don't remember how much it was exactly. A couple thousand, something like that, maybe. A couple $1,000s, I'd say. I got some rechargeable batteries for those clickers and a charger, so I wouldn't have to purchase new batteries. I could just charge them up whenever they got down, that sort of thing. Yes, sir.
How far does the average student go in math these days?
That's a great question. I wish I had a great answer. It kind of depends. At Olentangy, we kind of have the target of trying to get the kids to at least see a pre-calculus class. It doesn't always happen. There are a few kids who they go to Algebra III, or I have some kids who are in my Discrete Math class who, instead of taking pre-calc, they take Discrete, because it's just a completely different type of class. But by the same token, I have kids, I teach also AP Calculus BC, which, for those of you who don't know what that is, there's AP Calculus AB, there's AP Calculus BC. AB is like a first semester of college calc. AP Calculus BC is first and second semester of college calc. So technically, by the time they finish with my class, then they would be finished with a first year of calculus in college.
Does the technology that they have help motivate them?
I think so. I think that it makes it so that, like I said, you can do much more learning as opposed to the drudgery of doing the same thing over and over to try and figure out what it is. If you want to try and graph something to understand what's happening with this curve, I have to spend 5 minutes making a T-chart, plotting points to figure out what it looks like, and then try and do analysis of it. I can just start doing analysis of it because you can get that instant feedback. Yes?
Your outliers, you have 24 students and one of them is continually having trouble.
Mm-hmm.
He's going to have an ego, or man, you're showing that I'm not hitting the question. How do you deal with that that outlier situation?
Well, that's just one of those things where you just kind of talk with the kid and say, hey, what's going on? It seems like you're not getting it, or you're not working to the level that I think you should be working. And that happens. And there are kids, I'm actually kind of in a good situation. The courses that I teach, I really do have motivated kids. The one class, the discrete math class, is one where sometimes I get some kids who, the reason why they're in discrete is because they didn't know where else to go. For discrete math, just to let you know a little bit about it, it's a class that talks about mathematics that you've never seen before, like with number bases. That's not normally covered in a math curriculum. But it's something that it's very interesting, and it's something that I think it's good for the kids to understand. It helps them to think a little bit better, just in general, about whatever it happens to be. So I really try and, in discrete, talk about thinking skills and problem-solving skills. And for some of those kids, it's going to be, well, look, you don't have to do this, but you also don't have to pass my class. I'm just kind of straight up with them. I mean, I also, like I said, I teach AP Calculus BC. Those are motivated kids. And I have kids who are in there who, honestly, they're some juniors who are in BC. So next year they'll probably take college classes. They'll do what's called post-secondary. So they'll take some class, they'll go to OSU or something like that. Yes, sir.
Do you have any idea or sense of how broadly this sort of technology that you're using is being used by other teachers in the Olentangy District or more broadly in Central Ohio? How rare or how common is this?
It definitely varies. There's some school districts who can't afford to do some of the stuff that we have, like that ThinkGates program that the district paid for that online ability. I think what our district was doing was, by doing that ThinkGate, it's letting everybody have a common place where they can develop quizzes, lessons, things to get more data. We're definitely a data-driven society. We want to know why we get the results we do and what they are as quick as possible. There are school districts. I went to a very small rural district. I went to Utica High School, teeny tiny place. They don't have all this same stuff. But as a teacher, you certainly, like I wrote the grant in order to get the smartboard and those clickers. You can, as a teacher, it doesn't have to be, we have that great Olentangy Education Foundation, but there's other places that you can write to get grants, like NEA has some great grants, the National Education Association.
Yeah, is Columbus using this? Do you know the teachers in the Columbus?
I don't know. I don't know how many are doing it. And again, it varies. Like, I try and use a lot because of my background. My master's is in instructional technology, using technology type things in the classroom. So that's like my thing. And there are a lot of teachers in our school who use the Schoology. They may not post videos. Some of them don't like to hear their own voice back. I don't care. My voice is my voice. But they can do different things. They may post lessons. They may post homework up on there. You can turn in assignments up on Schoology, so you can do whole things digitally. If you're an English teacher, you can have them turn in a digital paper. Just have them upload it into a Dropbox, and that's it.
Very good. Well, that's a question.
Thank you.
Before you take your seat, Dave, an excellent presentation, and we'd like to express appreciation to all of our speakers by donating a book we will donate a book in your name to a school where we do tutoring.
Very cool.
Okay.
Thank you.
Thank you, Dave.